Hello, welcome to the short lectures in physics. The topic for discussion today's session is terminology used in kinematics. The most of the terms commonly used. We will discuss about those things in this session. Mechanics is a branch in physics that deals with the studies on motion of bodies, influence of forces and their interrelationship, which are further divided into statics that deals with the bodies at rest without moving, staying at one place. Kinematics that deals with studies on motion of bodies without paying much attention to the cause of motion. That means we don't bother what is causing the motion. And also it won't consider the size, mass and shape or geometry of the body. Whereas the dynamics deals with studies on motion of bodies taking into account the cause for the motion, in particular forces acting on the body. So these are the subdivisions under mechanics. The body is said to be at rest if its position does not change with the time when observed from a particular observation location. And if it changes its position with time, then it is said to be in motion. So the terms rest and motion are with respect to a particular place of observation, which is known as the frame of reference. So the frame of reference is important as far as the studies are concerned. Example is observing objects on Earth from a stationary space station. Let us understand the types of motions. Translatory motion. When an object is moving, each particle in the body moves or displaces through some distance in a given time interval. Then we say that it is translatory motion. Example is a solid box moving on the floor. If a single particle is moving, that means instead of a large size body, a small particle like thing is moving, then it is known as rectilinear motion. Then rotational motion or rotary motion. In this, particles in the body, except those lying on the central axis, they move in a circle. All particles in the body move in a circular path. That is called a rotational or rotary motion. Example, a cylinder rolling on the floor. If a single particle or a point of mass is moving in circular path, then it is said to be circular motion. Example is a stone tied to a string and made to move in round or in a vertical plane. Next, oscillatory motion. In this, the body is made to move to and fro, that is back and forth, about its mean position, that is central. When it is red, it stays in a fixed position, that is the mean position. So about around that mean position, with reference to that mean position, the body makes to and fro, that is back and forth motion, that is oscillatory motion. Example, a swing, children playing swing, pendulum of a wall clock, etc. It is said to be executing simple harmonic motion. When its amplitude, that means the amount magnitude of movement from its mean position to either sides of the mean position, that is known as amplitude. When its amplitude is very small, then it is said to be vibratory motion. Example, spring movement, gas molecules in a closed container, etc. Now another important aspect is to indicate the location of a point in a space, because most of the times we indicate the position of the object in space as a point. So consider a XYZ coordinate system, that is a rectangular coordinate system. Let its coordinates of a point be indicated as X, Y, Z. That means we have to move along X axis through X distance, along Y axis Y distance, along Z axis Z distance. Then you will arrive at point P, that is XYZ as shown in the figure. The coordinate system is considered to be an independent entity and with the time dimension added to it. That means xyz is only distances. If you add a time uh, dimension also to to this entity, then it is known as frame of reference. That means why we are talking about time is the position of P with the time can be identified in this xyz plane of reference. Point P is said to be at rest if its coordinates do not change with the time. If one or more of it, that means either x or y or z or all or two, any of the two, change with time, then the point P is said to be in motion and with reference to the xyz. It is said to be moving with reference to xyz system. If you observe from other reference system, the situation will be different from that what you observe from this xyz reference system. Let us know some more terms. Distance. Distance is the length of the path traversed by an object in a given time interval. That means, for example, point P is changing its position from P to another point in a given time interval. Then the magnitude of that path traveled by the body in that time interval is known as distance. It is a scalar quantity, and in SI system its unit is meters. Its value cannot be negative, always positive, no negative. It can be 0 or it cannot be negative. Next term is displacement. These are also similar, but it is a vector quantity. Displacement is the shortest distance between the initial and final positions of the object in a given time interval, irrespective of the path that the object has taken. I mean, the object may take different routes, but finally it reaches the destination. So the shortest distance between the initial and final positions is known as the displacement. And it doesn't matter in what direction it has gone to the final destination. And it is a vector term. It can be positive, negative or 0 even though the object travels a certain distance. Positive, negative you can understand because depending on the direction, one direction is positive, other direction will be negative. But 0 uh, is important because whatever it might have traveled a lot of distance, but finally it comes to the initial position, then the displacement shorter distance is 0, hence the displacement can be 0. Hence it is a vector term. In one-dimensional motion, the magnitude of displacement and the distance both will be equal. Now in this figure you can clearly understand what is the difference between displacement and distance. Consider a point P is trying to reach point Q in some time interval. So it is taking the path PRQ, the upper portion of the figure. PRQ is the path it has taken from point P to point Q. So while the distance is the total length of the path PRQ. So distance means you have to measure all the curved path as indicated as PRQ, but the displacement is indicated by the vector form PQ, that is the shortest distance, PQ direct, that is the displacement. Distance is PRQ, the total traveled displacement. Suppose let us just see that the point from the body from point Q returns back to Q taking other route QSP. Then the total distance traveled by the body from starting point P going to Q and then returning back to P is PRQSP. But the net displacement is P to Q it went in one direction, Q to P it returned in the opposite direction. So the net displacement P to P is 0, hence the magnitude of the vector PQ becomes 0, hence the displacement is 0. So if the body is moving from P to Q, the displacement is PQ, but if it is returning back to Q, the displacement becomes 0. Then, like displacement distance, we have two more terms, speed and velocity. Speed is the distance traveled by the body in a unit time, that is distance by time. Its unit in SI system is meters per second or kilometers per hour. Dimension is m0 l t minus 1. The speed can be positive or zero as scalar quantity. If a body covers equal distance in equal intervals of time, that means same distances it is traveling through in a given time intervals, then it is said to be moving with uniform speed. If it is covering unequal distances, means the distance traveled in given time intervals of time is not same, then it is said to be moving with variable speed. Now coming to velocity, velocity is the displacement of a body in a given unit of time. So that is displacement by time. Same way, the speed, the units are meters per second or kilometers per hour, and dimension is m0 lt minus 1. It can be 0 or positive or negative depending on the direction of motion of the body. It is also vector quantity. If a body covers equal displacements in equal intervals of time, then it is said to be moving with uniform or constant velocity. If it covers unequal displacements in equal intervals of time, then it is said to be moving with the variable or non-uniform velocity. So, like speed, here also we have uniform or constant terms and variable or non-uniform velocity. Change in either of the magnitude or direction may result in such situation. Because velocity is a vector term, even the magnitude change or direction changes, we say the velocity is changing. Hence the variable velocity term has come. Now, when the speed or velocity are changing, we get two more terms: average speed and instantaneous speed, average velocity and instantaneous velocity. So average speed is the ratio of total distance traveled with total time taken. Average velocity is the ratio between total displacement with the total time taken. That is when it is moving with uniform speed or velocity. Body is moving with variable speeds or variable velocities, then its speed or velocity at a particular time is called instantaneous speed or instantaneous velocity. If it is moving with uniform values, then we can take average speed and average velocity. But if it is moving with the variable or non-uniform values, then we have to calculate instantaneous speed or instantaneous velocity at a particular time of interest. Let us see in this example. Let a body be moving in same direction, covering distances s1, s2 up to sn in times t1, t2, t3, tn respectively. Thus having instantaneous speeds or velocities v1, v2, v3, vn, etc. Then we will calculate its average speed. So the average speed is not, because the displacements are changing with the time for each interval of time. So the average speed is not equal to summation of the distance by summation of time. That means it's not equal to sigma s by sigma t, but we have to calculate like the procedure shown below. One is total distance traveled is s is equal to s1 plus s2 plus s3, that is sigma s. Time taken is equal to t is equal to individual intervals of time we have to calculate. So s1 by v1 plus s2 by v2 plus etc. sn by vn. Because s is equal to vt, t is equal to s by v. So time should be calculated for each event s1 by v1 plus s2 by v2 plus s3 by v3 plus up to sn by vn. Then average speed becomes v average is s by t. Time taken we have calculated in a different way. So the average speed becomes s by t. If s1 is equal to s2 is equal to, say only two events are there, then S1 and S2 both are equal to same, then S average is equal to 2v1 v2 by v1 plus v2. Total distance S is equal to, now we can calculate in a different way, v1 t1 plus v2 t2 plus v2 v3 because S is equal to vt. v1 t1 plus v2 t2 plus v3 up to vn tn summation, you can take product of velocity and time terms. Then time taken is equal to t is equal to t1 plus t2 plus t3 plus up to tn. Then average speed is given by v average is equal to s by t. If t1, t2, if only two, three events are there. T1 is equal to T2 is equal to T3 is equal to T. Then S average is equal to V1 V2 plus V3 by 3. S average is equal to V1 plus V2 plus V3 by 3. Like that we have to calculate the average speed. Now, when an external force acts on a body at rest, it makes the body to move. So when a force acts on a body, if it is moving and gains speed or velocity in a given time interval. Both cases are possible. Force can increase the speed or decrease the speed. So if the force increases its speed or velocity, then the body is said to be accelerated. That means increase in speed. So the increase in speed or velocity with time is called acceleration. Similarly, if the force decreases its speed or velocity, then the body is said to be decelerated. So decrease in speed or velocity with time is called deceleration or retardation. The velocity of a body traveling in a straight line changes by, we are now avoiding to discuss about the directional changes. So body is moving in a straight line, let us assume. So then the velocity of the body changes by equal amounts in equal intervals of time. Then the body is said to be moving with uniform or constant acceleration. We got like speed and velocity, here also uniform or non-uniform cases. So if the velocity changes, magnitudes are same in given intervals of time, then the body is said to be moving with uniform or constant acceleration. If the velocity of the body changes in magnitude or direction or both at different times, then the body is said to be moving with variable or non-uniform acceleration. So here also average acceleration is the ratio between the change in velocity and time interval delta t with which the change occurs. So these are the some of the terms we regularly use and how it has to be used have been explained. Hope this finds useful to you. See you in the next talk. Bye.